When you read a problem, look at all the numbers and especially their units and kind of analyze what you have given to decide what you're going to do. And so as I read this one, I see a temperature, and then I see a pressure, and then I see another temperature, and I'm asked for a new pressure. So because I have two temperatures and apparently two pressures, I know that this gas is undergoing a change. So I'm going to sort this out. This is before and the temperature after, the pressure before, and I'm looking for the pressure after. And so the equation that we know for a gas that's undergoing a change, like this one being heated, is this one. This is the general equation, the combined gas law. I can start with the combined gas law and then simplify it for this situation. And what I notice is that nowhere in this problem am I given a volume. So I need to make an assumption about volume. Whatever number V1 is, it's the same number for V2. Volume is constant. And if it's constant, I could divide both sides by that number, and V would cancel out on both sides. And so I'm left with Gay-Lussac's law. So now I can plug in my numbers. Oops, and then I see something I need to do before I plug them in. Remember that on the combined gas law, pressure and volume need to match. In other words, I have atmospheres for both, but temperature must be in Kelvin. So before I plug in, I need to convert my temperatures to Kelvin. And so let's do that. So my temperature was T1 is 23 degrees C. I'm going to add I'm going to use extra digits even though I really only have 3 and I can keep track of that. Okay, then I'm going to continue where I was and plug into these. Okay, and however you want to do the algebra is fine. What some students like to do is to cross multiply just to get rid of the fractions first. But however you want to show the steps, I'm going to cross multiply, which means top times bottom equals top times bottom. And then I'm going to divide both sides by this 296. I'm keeping track that that temperature only has 3 sig figs, but the pressure does as well, so. Okay, and when I do that, of course, the number and the units cancel here, And here the units cancel, the K, and then I can put that in my calculator. And rounding to 3 sig figs, my pressure only had 3. Again, I can ask, does that make sense? Well, in this problem, I'm heating up the gas, so I would expect the pressure to increase, and it did. It went from 0.98 to over 1.